Good morning once again, ladies and gentlemen. Welcome back to the Information Warfare Pavilion in the second session of our three-session day today. And this one I think you're going to find very interesting. We've got the digital transformation panel looking at the Theodore Roosevelt, and I'm going to turn it over right away to Delores Washburn from NIWC Pacific, who's going to moderate the panel, and I will just let you get started.
Okay. All right. Thank you, everybody, for attending today. And welcome to the Digital Transformation Panel. I want to let you know that digital transformation was just kind of a little bit too broad for us. So what we're going to talk about today is we're going to talk about digital transformation, but then we're also going to talk about how it's being applied to the specific use case of the Digital Theodore Roosevelt Carrier Strike Group. So I think this will make it more interesting to see specifically how we're taking digital transformation and applying it today and making a difference today, and especially making a difference in this particular use case, the Digital Theodore Roosevelt. So I want to begin by just thanking our panel members. We have leaders from across Naval. You know, we have a very important role in Naval in terms of the information warfare domain. We know it's always evolving. We have disruptive technologies like every day. Industry is definitely our partner in bringing the latest that we can offer to the fleet. And so being able to have an environment that lets us be digital, that lets us rapidly change and adapt is really key. And so that's why digital transformation is so important. And then what we're doing with Digital Theodore Roosevelt is really transformational. And so I'm excited to introduce our panel members today. As I mentioned, these are leaders across Naval that are actually right in the mix. They're actually doing the work today, rolling up their sleeves and making it happen today. But we have, to my immediate left here, Dr. Bob Parker, who is the APEO-E Technical Director. Next to him, oh yeah, thank you, wave, nice. Next to him is Steve Crosson, who is the Assistant POC4I for Engineering. And then next to him is Mr. Rick Jack, who is a Senior Scientist for Software at NIWC Pacific. And then finally there we have Mr. Tim Gramp, who is the Deputy Chief Engineer at NIWC Pacific. Okay, so I just want to let you guys know, just to center yourselves, this slide is going to be how we ground ourselves and talk about digital transformation for the Digital Theodore Roosevelt today. So we're going to be referring to it multiple times today, just to kind of focus it in on the efforts that we're doing to support the Digital Theodore Roosevelt. We're going to talk about some of our digital engineering processes. The four on the bottom there are the ones that we're really going to drill down into and get specific on. So just so you don't get lost, that's what we're going to talk about today. So you're going to hear from each of our panel members who are going to talk about each of those four processes. But just to start off, just to kind of have the big picture of how it all ties together and to set the stage, I'm going to ask Dr. Parker if you could kind of give us a big picture of what this all means. So over to you, Dr. Parker.
If I'm right here, can everybody hear me okay? How about this? Okay, thank you. So I believe that I could go out and I could ask everyone in the audience what digital transformation means to each of you, and I'm pretty sure that by the end of that exercise we would come back with a very, very wide variety of answers. So what does digital transformation mean in the context that we're applying it here? Over the last couple of years we've taken inspiration from a lot of different places, the digital transformation efforts at Naval, product lifecycle management tools, Industry 4.0 for folks who are tracking that, especially the digital threat efforts, and we've tried to look at those tools and try to figure out those are all great, but how do we apply them to the tactical environment? Namely, how do we take advantage of digital engineering to do the following? Deliver capability faster, deliver well-integrated capabilities, provide better quality software products, and also provide better cybersecurity baked into the products that we deliver. So how do we do all that? So first, what we're looking at doing is we're looking at integrating a suite of digital engineering tools in our end-to-end product delivery, or capability delivery. So what you'll be seeing here is discussions on model-based system engineering, digital twin, tactical core services, and DevSecOps. The panels will discuss each of these in short order, but when I look at it from a very broad point of view, I'm looking in two dimensions. One, for our application space, I'm looking for vertical integration, where we're integrating applications against a set of common services and an infrastructure and inheriting security controls from each. And as we'll talk about, that's something that helps us achieve speed for accrediting applications. But we also want to introduce horizontal integrations between applications so that we can build workflows. One of the things that Don CEO mentioned yesterday is the fact that a lot of warfighter integration gets actually integrated by the warfighter. And we think we can be smarter than that. The tool should actually be accomplishing that and letting them exercise their expertise in their art. So all that covers the digital part. So where does the Theodore Roosevelt come into the discussion? So as we mature how we're trying to apply digital engineering techniques, it makes sense to try to sync our efforts to strike groups as logical points to deliver capability end to end. We want to use each of the strike groups to successfully provide more integrated capabilities, and we want to get away from the paradigm of delivering monolithic applications. Instead, we're going to focus on integrating our applications to provide system-of-system capabilities like battle space awareness. So we want our IW programs to cohesively come together to provide an integrated platform, which in this case will be the information warfare platform. Finally, for industry, we want to be able to use digital engineering to harness more innovation. At times, trying to insert capability into our architecture, there's a lot of friction, a lot of delay. So we want to use digital engineering to lower the cost of introducing innovation to our information warfare platform. We also want to provide a process for our sailors to be part of the development process so they can contribute ideas and also let us know what the priorities are and what fixes are required instead of just being a passive end user of the capability.
Okay, thanks, Bob. So that kind of sets the stage, kind of the big picture. And as I mentioned, we're gonna refer back to this, and in particularly just kind of focus on 4 specific areas: model-based systems engineering, digital twins, DevSecOps, and tactical services. So I'm going to now ask each of the panel members to speak to that. But I would let you know, after we get through a couple of questions, we really are interested in questions and dialogue from the audience. So be thinking about your questions and be writing them down. But to start with, I'm going to ask Steve. Steve, if you don't mind, could you please talk about the model-based systems engineering and how it's being applied to our use case, specifically the Digital Theodore Roosevelt Carrier Strike Group?
All right. So Bob started off with big flowery language, and now I get to be the more boring and rudimentary guy. So one of the things we consistently struggle with, despite all the big ideas around digital transformation, is just basic interface management between applications and other applications, between applications and infrastructure services, between applications and hardware infrastructure as well. So where Bob said, if I asked the audience for your definitions of digital transformation and we'd get 100-some answers, if we asked a slew of applications riding on canes how they're best interfacing with canes, we'd probably get a bunch of different answers for that as well. And that doesn't mean one's better than the other, but it just means there's some differences in interpretation. And when you're trying to do something as wide-ranging as digital transformation for capability delivery, you want to minimize that variability to the greatest extent you can. So when we say MBSE, that's also not a new concept. That's something a lot of our programs at Naval have been doing for quite a long time. What we're trying to do is make that an intrinsic part of the process earlier on and make sure that those models are not kept just within an individual development team's purview. So what does that mean? So we talk about designing in interoperability. We talk about using Agile methodology for software development. We talk about all these things that are the newer wave of how we're developing systems. We still run into things at our Big Bang integration events where 2 programs read an interface control document different ways. I was giving you tracks and you were receiving tracks, and yet somehow we still didn't have the same formats when we transmitted them. So how do we catch that far, far to the left of that? So everybody in their programs do design activities. They all do architecture activities. We're now taking all the teams that do that across the individual applications and bringing them together in system-of-system models early in the development cycle. And the other difference is those models are no longer just references for development, but actually using them for modeling and simulation, right? So you put your interfaces together, there's a mismatch, somebody's got to go back and change something. Well, we build that into a program's backlog. right? So you're not just updating the model, you're updating the code as well. The other piece that we're trying to emphasize, and we'll talk about tactical core services in a second, is common use of infrastructure software services. If folks are not taking the most advantage of the software services, one, that makes things like data sharing, data availability a little bit more difficult to manage from application to application. Two, it may mean you're not getting the most out of the software services that you can. So making sure that we're sharing that data across in terms of, hey, the best way to interface with this common software service is the following, and making sure that's documented and carried all the way through. The other piece we're trying to do in relation to the TR specifically is emphasizing about a dozen programs that are bringing new releases, new capabilities, or first of capabilities to the TR to make sure we integrate those right the first time. So that doesn't mean those are the only ones we're focusing this methodology on, but they are the ones we're placing the greatest emphasis on, and the ones that we have integrated all the modeling teams together to make sure the modeling efforts are supporting both the individual programs and the capability deliveries as a whole. Now, part of that also means carrying these models through going forward, right? So we're going to have this effort for the TR strike group. That doesn't mean we start from zero the next time around, right? A lot of these systems are going to continue on, continue being upgraded. So how do we make this model baseline the new starting point for all new capabilities going forward? And then how do we integrate models for the leave-behind capabilities that maybe aren't being upgraded on any given strike group to integrate those as well? Because that's an area we also have a lot of challenges. You bring a new capability and you focus on how to integrate it with the other new capabilities, but you don't pay as much attention to the leave-behind capabilities that you're also going to take advantage of. So that's a very wide-ranging set of ways that we're using this. MBSE is a tool set that we're using to do it, but the key is not necessarily the tool set in and of itself being the solution, but the way we attack this as not 12 individual applications, but a whole suite of capabilities being developed as a cohesive whole.
And I'd also like to add what I think is exciting about it, too, is it's across all competencies. So whether you're a developer, a tester, a designer, a project manager, a logistician, you're all going back to that model to do your work, to have a single source of truth. So it's really changing our culture as well, and that's super exciting about doing model-based systems engineering. Okay, now I'm going to bounce it back to Bob, and I'm going to go to another one of our engineering, digital engineering processes here. But I'm going to ask Bob to talk about tactical services, and again, how does that apply to the Digital Theater Roosevelt?
Okay, so we have to recalibrate the microphone again. Still good? Okay. So as I mentioned earlier, we want to integrate our applications both vertically and horizontally, and that has a lot of implications for our application architecture. Both of these approaches, both the vertical and the horizontal, are facilitated by providing applications with a set of common services. I want programs focusing more on delivering their core capabilities and delivering a bunch of housekeeping services that allows them to provide more value and spend more of their time giving the IW community something they want. To that end, we're going to provide a paths afloat for applications that provide a large number of services, but some of these are container orchestration, data and analytics services, identity management, mapping, visualization. Again, a core set of tools that every application can count on. The PaaS also provides us with two other very important functions. First, the PaaS insulates or isolates the application from the underlying infrastructure. So if I develop to the PaaS, I want my applications to be able to target the Canes environment, the tactical shore environment, and operational cloud environment. Develop once, integrate against all of these, and deploy quickly. The PaaS also, along with the underlying infrastructure, and let's think of Canes software here as an example, provides an inheritable set of security controls. So when I have a program go forward to go through the RMF process to be certified, they shouldn't have to go and worry about 100% of the controls. They should be looking at what they're inheriting from the infrastructure and what they're inheriting from the PaaS itself as well. Then they have a much smaller set of controls to satisfy and then go through certification much faster. And then looking into the future, we also want our applications to start breaking themselves into microservices and implementing API management schemes. I'm looking for each one of our applications to provide a set of mission services. We have common services. I want a set of mission services per application. The mission service will be things like I want to be able to provide METOG services to other applications. I want to be able to provide operational planning tools services to other applications. That allows us to integrate our workflows and, again, put the applications in charge of mining the data and building knowledge for the warfighter instead of them having to do it themselves with a series of PowerPoints or lots and lots of sticky notes. Containerization is also an important part of our near-term strategy, and both from a point of view of being able to rapidly deploy updates at the container level, but also to be able to provide ways to scale performance that we can't do right now, where we might possibly provide static virtual machines to applications. I think in the future, as we're trying to deliver many more capabilities, orchestrated in ways that we haven't foreseen, being able to auto-scale becomes very important. Now, a lot of that is, as Steve said, are kind of fluffy words, so what are we actually doing tangibly? So part of the problem with deploying a PaaS is that you're trying to build trust, and you're trying to build trust between the applications and the infrastructure. An application provider doesn't want to build against a PaaS and build their entire baseline against that just to find that the infrastructure is not going to provide it. So then that becomes a bill on the program. Likewise, if the infrastructure, say Canes, for example, is going to bring a PaaS, they don't want to bring the PaaS in, there are no customers. So we're tying up funding and licensing costs, and we're creating an attack surface for no general purpose. Our current PaaS that we're providing right now is called Agile Core Services, and we've probably talked about it in multiple forums. And it's currently based on Red Hat OpenShift and several of the commercial solutions and open source software solutions. The current version is building this year, and we're putting additional funding into ACS to build a critical mass. So by the end of 21, we're going to be on about 30 platforms to help kickstart our building. Looking at the TR Strike Group, we also anticipate that we'll have ACS employed on most of those ships, if not all. So we'll be able to carry forward a comprehensive, well-integrated set of ACNS-enabled applications for the TR.
Okay, great. And so I mentioned when we first started off, like the importance of how we know that the information warfare domain is evolving constantly, and the threats are evolving, and there's disruptive technologies that we want to harness and put out there for the fleet. And so this kind of architecture in the tactical services is a huge enabler for that. But in addition to that, another big enabler for being able to rapidly get the latest technology out there and capability out there is DevSecOps, which is our third engineering core process that I wanted to have Rick Jack talk to.
Oh, thanks. So I guess I'm not the flowery person, I'm the buzzword person. I swear we could make a game out of how many times DevOps or DevSecOps is used in this conference, and I'm sure you'll hear it a lot. But I think what we're trying to achieve here is really the question mark, and Digital TR is really the implementation example of what we're really trying to do. So in theory, DevOps or DevSecOps establishes what we call parity. And the challenge for us in the military domain is how do we do that while leveraging the harnessing the power of industry? So either one of two things. Either we can deploy developers to every ship, or we could deploy every ship to every developer. That's how you achieve parity, right? So the developers have to understand the dependencies and employ a solution that meets its objective. But what we're trying to do for Digital TR is kind of like this ability to bring the two together, to harness this idea of operational parity in a way that can achieve access. We can bring our developers in, and to have a representation of these kinds of informant things, the dependencies. You've already heard about the model-based system engineering side of the equation, and adaptation of what we call enterprise services, and leverage to harness the power of the PaaS. But to be clear, DevSecOps isn't a thing you buy. It's something you achieve, right? It's almost like, anybody heard the word agile, right? Agile's not something you do. It's something you are. It's an adjective. So the question is how do you know when you got there, right? So how do you know you're being agile? How do you know you're doing DevSecOps? So Digital TR is a way to implement the tools, processes, people, and technology side of the equation together to harness the power of all those activities, right? To do them in such a way that we can execute a pipeline or a set of processes and procedures that are normalized and rationalized so that the people at the end of the pipe understand what we're achieving. We can make what we call data-driven decisions based on artifacts and understanding. So when we talk about DevSecOps, it's really bringing the communities together to include the security groups, the test and evaluation groups, and so that we can get out of this guessing game of trying to understand what the answers are at the end and shifting everything left. So Digital TR is actually a reference implementation of those kinds of things. We have the power of the cloud that we're bringing to bear. We brought together the tools that we can kind of normalize and rationalize along the way. The platform as a service. Everybody has the same environments so that when we achieve these things, at the end, the program executive offices can understand and make data-driven decisions on whether the effects are being achieved. And when we talk about effects, what we're really talking about is outcomes, right? Working to the idea that we're measuring outcomes as a variable, and that's what we know we're making a difference. And I'm proud to be a part of this because Dr. Parker and Steve's implementation of the Digital TR is where we really get to practice this. So this is where we really start to exercise and understand if we're truly being agile and we're truly doing DevSecOps.
Okay, and now we have our last digital engineering processes that we wanted to talk about before we start opening up for questions. Who can guess which one's the last one that we haven't talked about? It's a digital twin. Okay, and then also I just want to point out that wonderful digital twin graphic that we have right there too. So I'm going to save this last question for Tim. Tim, can you please tell us what is the Digital Theodore Roosevelt digital twin?
Thanks, Delores. So the first thing I have to do is kind of unpack what is a somewhat overloaded term there, digital twin. For the folks in the audience that are modelers, for the folks that are MBSE practitioners, there is what Steve referred to earlier, talked to earlier, is the model of the system that we can simulate and the data that drives our decision making. Another aspect that we've used that digital twin concept on is to talk about what Rick just mentioned, the parity between our development target, our operational target, and our development environments. So in this case, I'm going to talk, because Steve already talked a little on the modeling side of that. I'm going to talk about that, how we're using, in this case, the commercial cloud to provide an operationally representative environment further to the left in our development cycle to enable that more rapid DevSecOps delivery. So that parity word that Rick used a moment ago, one of the big drivers for DevSecOps is the drift that occurs between a platform that's deployed and what a developer is working on. And naturally, the longer that it takes you to deploy code, the bigger that drift gets. So a key enabler for DevSecOps is to reduce that drift. And how can I do that? Again, as Rick mentioned there, we can bring that end state to every developer. So on the digital twin idea here, what we're doing is automating the deployment of that final, in this case, the shipboard, in the case of the Roosevelt, that Canes infrastructure, that ACS for the services that were there, we're automating that deployment, putting it into commercial cloud, and making that available for every developer as an exact replica then of what the deployed system will look like. That gives us several kind of benefits. We can do a better configuration management. As we know, we can take information off the deployed target, off that Roosevelt Strike Group ship, and pull that back into our virtual representation, our digital twin. And now, again, we've kept that parity closer. It also allows for earlier testing. Again, we don't have to wait for big bang integration events. We can pull that to the left, and with every check-in of code that a developer makes, with every commit, that can instantly be run against a replica of that deployment target. So it allows us, again, it improves our configuration management. It improves the likelihood that our capabilities will succeed when deployed. It'll improve that test success. And it also improves that horizontal integration that was talked to earlier. With several different systems that may be developing in a stovepipe, we can now, at earlier development time, ensure that they're working against the same baseline, the same set of services, and it improves that, again, efficiency and that likelihood of success on deployment. So yeah, that's...
Okay, thank you. So now I have just a couple of questions, but be getting your questions ready because we're going to turn it over to the audience in a second. But I did want, Rick, I'm going to direct this one to you.
Okay.
So we've heard a lot about compile to combat in 24 hours, and a lot of the things that you guys are talking about all get us to the point where we can do compile to combat in 24 hours. But can you explain how this enables compile to combat in 24 hours?
I've never heard of compile to combat in 24 hours. No, I'm kidding. How this enables, so we have this conversation a lot with all the warfare domains with respect to compile to combat in 24 hours. So to be clear, compile to combat in 24 hours is a framework. It's a framework that enables the ability to deliver capability quickly to meet warfighter effect, right? We're trying to drive the effects part of the equation. The challenge that we held before us was it's too easy to talk about development activities in a vacuum and or all the other activities in a vacuum when we don't bring them together in a holistic solution. So when we talked about compile to combat, the idea was to drive the two together, we have to work what we call the friction points of enablement. And one of those friction points was what we call shared infrastructure. So it was super easy to apply the information development execution plan because it had a very holistic strategy or a very defined strategy for how to achieve the number one pillar, which was shared infrastructure. When we could bring and harness the idea of cloud to that equation, which was the idea of achieving parity, we could implement the execution plan in a way that we could bring our developers to bear also. The hard part that we were trying to solve was, well, what does that look like? So one of the challenges we had was, well, we could do this in a very commercial-oriented way, or we could do this in such a way that kind of enabled us to develop at the level that was necessary, that didn't necessarily uncover the keys to the kingdom, right? So there is some what we call security and intellectual property that we have to kind of take to bear. So it's not the open source as a whole model where we just do everything in public. So what we did was we took the C2C24 framework and we provided the cloud in such a way that could provide the shared infrastructure to meet the compliance level of the equation. You know, working with the SRG and understanding all the rules that were necessary, we had to do that and provide access to our developers. The other side of the equation was we understood that there was a lot of people spending too much time building up infrastructure. We're like, well, why couldn't we leverage the power of enterprise services, automate all of that, and provide that as a resource so our developers could get first day, first dollar? That, again, is yet another pillar of C2C24. So we had the two pillars aligned. Then once we had that, we could start working with our NAOs to figure out what our strategy for reciprocity was so we could get our developers out of the ATO game, which was, you know, oh boy, how do I accredit and secure my box, which was if the box is provided for you as a part of the infrastructure, you don't need to do that. So what this enabled us to do is really focus where the pain points were. Instead of worrying about accrediting boxes, we could have our developers focus on the really hard parts of the equation, like a secure application. We could actually make the applications more resilient. And so if we could do all those things in an environment, that enables the third part of the equation, which is the process. Instead of focusing on the mechanics of compliance, we could focus on security, resiliency, well-defined applications, ensuring they're doing what they really intend to do. So those are the particular pillars that compile to combat was intended to do. So what I would say is that the information warfare execution plan is a strategy to execute. The digital TR is a reference implementation of that exact strategy.
Okay. All right, I'm going to change subjects really quick, and we have to make sure that we definitely talk about data before the panel's over. So I'm gonna jump this one over to Steve. So Steve, of course, data's strategically important to us. but we have a lot of challenges. So what are some of the challenges that we're facing when it comes to data management between networks and applications?
All right, so let's say we use our modeling environment, we use the common syscom schema, we use the common functional definitions. Everybody's interfaces are defined in a common way. All the interfaces work, everything integrates. We've succeeded, right? What we still have some challenges in is the movement of data most efficiently both within the ship, from ship to ship, and from ship to shore. We have quality of service algorithms, we have all our various comm pipes, there's several S&T initiatives out there that we're looking at, but areas that we're still looking for new ideas with regard to are how are we maximizing use of our networks both in the ship and outside for communicating data? How are we defining data prioritization? How can we make data prioritization flexible based on mission sets? What's the most important thing one day may not be the most important thing the next day? And how can we establish those cues from the network infrastructure data that we have in terms of utilization, throughput, et cetera, to flag applications and have applications then know what to do, right? If I get a flag and said my network status went from green to yellow and I'm application X, what does that mean to me, right? What data have I decided I'm now going to stop pumping out so that I can make the most use of the limited bandwidth I have to get the highest priority data out there to wherever I'm trying to send it to. Same with sending from shore to the ship, right? If I'm going to replicate and synchronize data for enterprise sharing, how can I do that most effectively given the network conditions I have? We have a lot of work ongoing in terms of data environments, setting up data lakes, making data inside the skin of the ship more accessible, and federating that. But taking the greatest value out of the limited bandwidth that we're always dealing with is something we could certainly use some additional ideas on.
Okay, thanks. And I also want to mention, so digital transformation is a journey, right? And so Steve talked about some of the challenges that we have right there with data management. But what other gaps are out there? What do we need help with, and what can industry help us with? And Tim, I know you had some thoughts on that, so I'm going to kind of toss that one over to you. Thanks.
Thanks, Delores. So this is actually the greatest question because this is one of the most fantastic forums to be able to talk to you all about where our needs are still. And in this area of digital engineering, which is still very young, what digital transformation means, as Delores mentioned, it's a journey. Right now, we are taking still some of our existing ways of doing engineering, and we're kind of clunkily trying to attach, write that one down.
New buzzword.
We're trying to attach tools, and unfortunately, we're getting a little fixated on a set of vertical tools that aren't well integrated together. So when we talk about the modeling efforts, even within modeling, SysML, the implementations across different vendors for SysML, the modeling language for systems, is a little different. And it reminds me of old HTML days when a different browser would show you a slightly different thing even though we had a standard definition for HTML. So I think the ability to be consistent across our implementations is one key area. I think the flow of information between these different digital engineering tools is another really key area. Again, the models that we're using in our design, the models that we're developing in our user-centered design, have to be able to reside together in common repositories. They have to drive. If we are getting out of one tool and into another and recreating at some point, we've missed the entire point of all the automation that Rick spoke to earlier, and of really the key to this digital transformation, which is the seamless flow of information from engineer, from user input in, from engineer, designer, to builder, coder, to tester. That life cycle has to be fully automated and brought through. So again, helping the integration of those tools is really a key part. Another key area that I would touch on briefly is with the analysis side of this. There's a lot of emphasis on the front end, the modeling and the design, and the importance of data-driven decision-making. But unfortunately, on the analysis side, we still have very specialty-built simulation engines. It's not very easy to take a system model here and instantly do an analysis for performance or an analysis for other bottlenecks or breaks for interoperability. So I think we're still spending a lot of time building models and having to rebuild models for a specific simulation engine or an analytical tool. So helping us bridge that gap between system architecture and design and system analysis to allow truly that data-driven decision-making, I think is a real key area that we could use some help with. And again, it's bringing together the tools, bringing together those information flows, standardizing some of those data flows between tools, and helping to develop the variety of analytical tools, simulation engines that we need to support our digital engineering decision-making.
Okay, thank you. So I have one last question to the panel, and then I'm going to toss it over to you, the audience. So like I said, be getting your questions ready. But I'm going to ask Bob to kind of put a bow on all of this discussion and talk about what's the most important thing, which is what outcome do we expect for the Theodore Roosevelt Carrier Strike Group?
So if you're taking a look at the slide over there, pretty slide, but a couple of questions should kind of come up to you pretty fast, and that is, so what are we doing with the digital TR, with the TR Carrier Strike Group that we haven't done before? And then how does all this translate into new capabilities for the fleet? So I think one good outcome is that the ships in the Theodore Roosevelt Strike Group wouldn't actually notice anything. And the reason I think that is that, I've seen in the past a lot of software pushes that get delivered and we find problems kind of late in the process. If you go to update your iPhone, we do that all the time. iOS updates come out all the time, and no one thinks twice about doing it. And for the most part, every time you download software, it just works. For the information warfare platform, I want the same capability. I don't want it to be an iPhone because, as far as I know, no one's taking iPhones to war, but it should actually be pretty much that simple. You should be able to trust that the network's going to work every time you update new capability. So all that's not a very exciting objective, but it's still kind of important, but we are looking at 4 different things we do want to demonstrate. The first is we want to demonstrate our ability to develop, integrate, test, and certify capability updates to our applications during deployment. Not just deliver the TR with a set of applications. So what can I do 2 weeks after that? What can I do 4 weeks after that? Get out of the cycle, you'll see another update during your next deployment cycle. We need to be operationally responsive. Even better would be able to take feedback from the sailors to have them tell us what things need to be changed right now for them, and also what their priorities are. If you don't like the fact that we decided that black text looks great against a purple background, let us know. Let's try to make those kind of things easy to fix. And then ultimately in the future, this is past TR, but it'd be nice if we have telemetry built into our network stack, into our applications, so that we can get feedback on problems and remove the burden on the sailors of having to point those things out, or find areas for improvement, or find out parts of the applications that are being used more than others, so we know where to harden the applications at. And the idea of going fast is kind of a seductive one, but there's a difference between going fast and running with scissors. So if I say I want to push capabilities out to a ship like every day, if I'm a TICOM, I'm probably going to be horrified by that prospect. Because what has been done to test it? What is the training? What is the security? So how do we build an objective testing standard with our partners in the fleet so that we can move fast, but at the right pace? Second, want to be able to monitor for the TR, the number of trouble reports and CAS reps they report out on the applications we're tracking. Again, a hypothesis, we're delivering better quality. So can we compare our applications that are deploying with past patterns to see an objective improvement? Third, as we've talked about digital twin a couple of times here, we want a digital twin of the entire strike group. And that's to do a couple of things. One is, it'd be nice to validate patches and capability updates against the actual strike group before the patches go out. And if we can pull in the configuration data, the real-time configuration data from the ships, that can also help us very much in troubleshooting. Instead of having to send people forward to fix ships, pull the digital ship back to where all the expertise is. And then finally, we're looking for cases where we can demonstrate very smart application integration between applications using machine-to-machine capabilities. Whether or not we're looking to maneuver in spectrum, we want to take better use of our ability to characterize the battle space either through METOC, any type of GN tools. Want to bring in operational planning. I want that information pervasive across our application space so that we can find good ways to use all that data. And again, get the sailors out of the habit of having to be the human calculator or the human integrator of all that information. We have a tremendous amount of information afloat, but it's just trapped within like 100-some different applications. We can do better than that, And with the capabilities we're looking here for the TR, I think we're moving in that direction. We actually talked about this last year, if anyone remembered. We mentioned a concept called digital aid. So digital aid was our first attempt to try to apply some of these digital engineering techniques, but in each case, they were just pilots. So for digital TR, this is the first time we're trying to take all of these digital techniques and build out an end-to-end process to provide the fleet faster access to capabilities that are more well-designed, that are better integrated. I think we can kind of say we collectively believe that the digital TR represents the beginning of a more agile and operational responsive information warfare platform, which is important because it's a warfare platform that's already engaged in great power competition.
Okay, thank you. So I think the panel did a great job at explaining how we're using digital transformation and digital engineering technology and practices to meet the demands of that ever-changing information environment that we're expected to be able to respond to. And the good thing is like you've heard from the panel today, that we're actually putting it into practice today. So that being said, I would like to open up the floor. We have about 15 or so minutes to be able to answer any of your questions. I'm not putting you on the spot, but otherwise you'll just have to have me continue to ask more questions. Thank you.
Hi, my name is Megan Miller. I'm with MITRE, and I'm curious if you guys have any guidance with regard to Agile Frameworks. I know that scaled is framework, or SAFE is now kind of a scary word. Do you guys have any insight?
I think people have opinions about frameworks. So I think the question had to do more to a specific framework like scale. And for those who aren't familiar with scale, scale's what we call how do you apply Agile in a much larger context within an enterprise? And I think the pushback is well, how do you apply that as an enterprise if you're not doing it at the minute level, right? So as an individual product team, if they're not getting it right, you're never going to scale it in the first place, so why focus on scale? So I believe in that as a principle, yes, that's exactly the point, but I don't think that you have to throw out the baby with the bathwater. So from my particular perspective, if you're an expert in SAFE, for example, the Scaled Agile Framework, that's perfectly fine. And in an execution level, if you're doing that, I think it 100% applies. I haven't heard any particular framework that are diametrically opposed. For example, if you're using SAFE compared to Scrum, compared to Kanban, compared to extreme programming, all of those things are really good as long as you're disciplined in your approach, and that's what a framework does. So if you're using SAFE, awesome, do it. Whether we scale it or not is another question. If you're using Kanban, awesome, do it. But do it in a disciplined fashion. So when people like Steve or myself come into a particular program and we ask to see the artifacts that represent you're doing it in a disciplined manner, we expect you to follow those principles. So if it's Kanban, SAFE, or it doesn't really matter to us as long as you're being disciplined. So I think that's our particular point. We don't want to hamstrung anybody by gravitating and say, thou shalt do extreme programming and pairwise programming, because those, for a small project that may be 5 people, that may be a little bit of a challenge. So I don't think we're necessarily advocating that it has to be one versus any number of frameworks that work.
Okay. Megan gets credit for being the first brave soul to get up. So
thank you.
Don't let Megan show you up there. Who's going to be the next one?
Hi, I'm John Lieberman. I've talked with a couple of you before. There seems to be, just to be the sake of full disclosure, I represent several software companies that can provide a number of the functions that you've talked about. Certainly not all, but a number, particularly when it comes to data integration and flexible exploitation and delivery to multiple systems. It seems to me there's a strong emphasis on this DevOps approach when there are some COTS products that could go a long way, not a complete solution, but go a long way to helping you on your journey a lot more quickly than developing yourself each time.
So I know Rick is dying to jump on that, but let me otherwise we'll just have Rick talk for the rest of the afternoon. But so I will, though, I will channel my inner Rick and to something he said earlier. DevOps is not the tools, and I don't mean to challenge that there's a lot of tools that can really support us, but it's important to separate the cultural aspects of what it means to bring together the development team, the IT operations team, the users that are driving the needs, and that tooling is what enables us to do it faster through automation. And so certainly, when we say doing DevOps, there's a whole lot of doing DevSecOps that we need to do in the government in bringing together those various stakeholders. And there certainly is a place where a number of different tools, whether it's test and evaluation tools, security scanning tools, data integration tools, basically look at that entire process of what it takes to solicit a need, to produce a solution, to validate that it's the right one, and to give it to the user. And at any point along that way, if I am doing something manually that has me with a pencil and a paper checking a list or having to key something in, that is ripe for some tooling. And I think absolutely we're looking to not build or to try to too far zero down on one set of tools, but it's to look for those opportunities to use those tools at the right place to seamlessly enable the automation of that pipeline.
Thank you for that explanation. Appreciate it.
We got a guy right
So I'll ask you guys a question. Bob McPherson, Mainsail. So first of all, I'm all in on this stuff. I've got guys working on the digital stuff now. Some of the people on the Siemens program doing SIOP for Mainsail guys. So this is great stuff. I see lots of opportunity, condition-based maintenance, some of the things we've been trying to do, get the shipyard bottlenecks reduced and all that stuff. It's awesome. I also have a different perspective, having done everything from being an E1 messenger of the watch and lower-level engine room with paper log to being the OOD with the tactical action officer letter and weapons release authority. Having done all those jobs and solved all those problems, I know that when I could use that information the most will be when I'm in a deployed, data disconnected, or data denied, a disconnected environment. So if I'm the Repair 5 locker officer, I have an actual fire in the engine room, that data would be very useful to me to see on a screen. But the problem is that I'm going to have lots of other things to do. So you guys are doing some deep thinking. Do some deep thinking about how this doesn't become one more thing that the executors on the ship have to juggle in their day two. We've got to get to the point where the data, the information is just available to them. So I would ask you to consider that. How do you make it available in that kind of environment so that guys can use it?
So I think you highlight probably the largest problem we have, and that is how to have a resilient data environment afloat. Just throwing software at a problem isn't all of the solution, because I think we could load the ship down with so much software we would never have any chance of knowing how to actually manage all of that. So I think we're very conscious of the management burden we're putting on the fleet, but I think we're moving out on trying to do better data engineering for our applications. I don't think we can solve the problem you're talking about until applications actually understand what their data state is. Like which data has the most value to retain, which data needs to be replicated ashore. If you lose all connectivity, right now for the applications, I hope that we'd be able to tell you that these 5 datum are the most important ones to keep. The rest of them we don't care about. So we're going to be progressing, I think, in a couple of steps toward an integrated data environment, provide the data services to help applications do that. And as I mentioned before, I want the application stack, the paths, to try to hide that complexity. The same thing is going to be true with data. Almost every stage of data management we have right now is being replicated across every application, like ingress, data transformation, data storage, replication. Providing a common set of tools gets us in that direction, but also having a better understanding of our data lifecycle gets in that direction. I'd like to say we're going to have that solved tomorrow, but it's going to take a lot longer to do that. If I kind of look in the walk before you run, hopefully we're not crawling anymore. If I can just force applications to expose their data to other unintended users, that at least forces them to know their data well enough to know what provides value to provide. To that extent, though, to the end, we'll be looking at a variety of data lifecycle management solutions to try to keep our data problem under control and not, again, put too much of a burden on sailors. Again, I'd like the minute you lose connectivity, if that happens, I'd still like for you to be as effective as you were 1 minute ago. The question then becomes, how long does that drift occur? I think we can figure out what that decay looks like with better insight into our data. But a very hard problem. So, I think if we were to talk about, things we're looking for help in this area, data lifecycle management is probably number one on my list.
Okay, next question.
Gentlemen, Joe Nestor with Day 2 IQ. As we're looking more and more where the Air Force is going in the DevSecOps space and putting a heavy emphasis on open source when possible, can you guys share a little bit of perspective on where the Navy lands on leveraging pervasive open source technology versus vendor proprietary as a preferred outcome as you go through this transformation journey?
You want to do it for the pipeline?
Sure. So we actually love the idea of open source, but there is a trade space argument to be made, especially with if we think about who we're doing it for. So the technologist in me always prefers easy, fast, simple solutions. So therefore, open source tends to always be the gravitating answer. But when we actually think about who we're doing it for and our consumer base and who's actually doing the operations part, we have to. The trade space side of the equation is the complexity that we try to manage. So I'll just apply this to the dev side of the equation. I'll let Steve cover the ops side of the equation. So in the dev side of the equation, matter of fact, actually that's how we started. Was we said, hey, what things could we bring to bear to solve the conundrum of cybersecurity, doing static code analysis, et cetera, et cetera. And we all actually ended up with, I think our initial list was about 40 tools. And then I started thinking, wow, that's a lot of tools to manage and cycle. And if we think about open source moves at a lightning pace, right? GitHub repos shut down at a minute's notice. Major vendors buy certain things, so they tend to go away and be consumed as a part of a tool. So it was really a trade space argument. So what we tried to do was identify the tools that could give us the most bang for a buck and buy those as a part of the industry side of the equation. Like, for example, how do we do planning? How do we do collaboration? How do we align to the way that the developer community use? And then how do we buy a tool that means we don't have to sustain it spend a lot of time in sustainment, but we can focus on outcomes? So that was the dev side. Now, the prod side, or how we do it in as far as the platform, I'll let Steve kind of cover that one, because that's really an analysis of alternatives equation.
Yeah, so Bob talked earlier about Agile Core Services, which is our operational software platform. If you ever see a list of the products that are in ACS, you'll notice they're all commercial products. And you can put them on the open source spectrum, and they land various places. The key there is each one of those was selected based on an application or a suite of applications requirements and an AOA that came against that. Usually we want something supported, and I don't just mean supported in the terms of patching, cybersecurity support, or anything like that. I also mean supported in terms of helping our application developers take best advantage of it, right? So when we have a common suite of services, and we'll use the TR, the 12 apps that we're focused on there. I don't want 12 people figuring out 12 different optimal ways of using this technology, because that's not going to serve the purpose we want it to serve. So having, you mentioned Kessel Run and all that, a lot of the big things that I think people don't talk as much about with Kessel Run, or at least I don't hear it as much, is not the technology stack, but the culture they take to taking advantage of that technology stack. That's something we're also looking at implementing, is how can we find, whether a physical space, a virtual space, or both, an opportunity to bring the folks that are the technology experts, regardless of who that is, together with the folks developing the applications, so that we don't have that variability in common services usage. But also we get consistent feedback and consolidated feedback on when a tool isn't working as well, or isn't doing what we want it to do, or isn't as effective as it used to be. How do we get that demand signal more flexibly to upgrade what's in the operational software platform as close to the beginning of that knee in the curve as we can? and then take advantage of the remote deployment so that we can actually deploy updates to the stack to those operational ships, rather than saying, hey, we know there's a better way, but you're going to have to wait 12 months till you come into the yards for us to give it to you. So that's not one answer, but there's a range there.
Okay, and I see Mr. Pace. Great to see you.
Hi, Howard Pace. I'm with Naval Postgraduate School, Graduate School of Defense Management. My question is, I applaud the engineering discussion. It's a fantastic discussion. But given those 4 capabilities and those 4 processes, have you thought about how you're going to acquire this in the context of adaptive acquisition framework, and how you would approach it from a contracting perspective to get all this integrated together, considering the intellectual property discussion that you had earlier and all those kind of challenges?
So I guess there's some good, I'll kind of jump on this one because we were actually had the privilege to work with OSD on the acquisition side of the equation, which is a policy statement that actually Ms. Lord talked about this morning, which is a software acquisition pathways policy that just came out. That to us was moving the ball in the right direction with respect to an approach that solved some of our statutory and regulatory equations. The other side of the spectrum is in terms of how do we scale this contractually, or scale this to apply to the broad sense, the big O and the Don. That's why we considered C2C 24 a framework, which was really just something you could apply writ large to everybody. On the other side of the spectrum, we're actually working alongside DAU to align in principle how do we do this as a community and leverage the same fundamental processes. So we're working with DAU on the training aspects of it. We're trying to establish what a contractual strategy would look like across the board, so it doesn't necessarily equal a particular bottleneck. It's just something that would take an advantage at scale. And then you apply those to the SAP principles, and that's where the program offices step in and start to implement those in terms of frameworks.
Yeah, so I want to go from a program office perspective. So you see the 4 boxes over there? So how many programs have those as requirements to actually resource? I mean, technical core services, ACS, I can draw a pretty clear linkage to Canes there. But for the most part, these are tools that at least all of our applications are expecting someone to provide for them. They're definitely not funding them by themselves. So what we're trying to do is take advantage of the fact that there are investments all over the Navy. So just a couple of case points here. For model-based system engineering and tools to go with that, we're partnered with Naval. Naval has stood up the integrated modeling environment under the Digital Warfare Office. So that provides us one place to go to take access to a common set of tools with a wider funding base than just one of my programs. There's a lot of work being done across the Navy on SecDevOps or DevSecOps. We probably don't need 30 different DevSecOps environments, but if we start to take the best of breed across all the different syscoms that are working the problem, then we can probably come down to some that are sustainable, and then also offer them as a service across the Navy. At least within, just taking a look at within POC4I, again, my program managers will just say we're not funded to do this, but every program manager is funded to do development, and they're funded to do testing. So even within our program office, we can look at changing how program offices do business. Instead of maintaining 4+ development environments, and this is a made-up number, per program office, as you start to migrate toward DevSecOps, that's where the investment should go. And there's a carrot, and we usually have a lot of sticks, but there's a carrot there, because once you do that, you inherit a lot of tools, and you're able to move more quickly through things like the enhanced RMF process raised, and get capability out faster. So I think long-winded answer to your question is working opportunities across the Navy to find where the investment's occurring at the enterprise level, and trying to see these as truly what they are. They're enterprise tools that the Navy has a vested interest in funding. And then at the more tactical level, trying to drive program behavior to follow the same design practices, the same development practices, so we can achieve economies of scale there.
Okay, Great. Okay, so doing a time check, we're at the end. I'd like to thank you for the audience participation, and then I'd also ask you to join me in a round of applause for our panelists.